Today we're going to be talking about using proportions to solve problems. The main thing of a proportion, we have an equation stating that two ratios are equivalent. Remember, a ratio is also a fraction. And again, we're saying that these two equations, or these, it's an equation stating that these two different ratios or two fractions are equal to each other. If you recall, just a couple of videos ago, we did our percent proportion. So just to remind you, we said that is over of is equal to the percent over 100. And we use this right here to determine the is or the of, or how much money was a percent of something, or not money necessarily, it could have been anything. But when we did this, that is an equivalent ratio to the percent. So the is over of is one ratio, and the percent over 100 is our other ratio. All right, cross products, you might have also heard this as cross multiply. That's how I've always said it as I was growing up, is always said cross multiply. But what we're talking about here is we are talking about the products of the terms on the diagonals when two ratios are being compared. And I'll explain more about that with our next little example that we're going to do here. But basically, again, it's the products of the terms on the diagonals when two ratios are being compared. So let's see what that really means. Okay, we're going to take a look here, and we're going to determine if two ratios are actually in a proportion or not. So I'm going to look at this. I have 2 over 5, and I'm going to say that that's equal to 4 over 10. Now you might look at this and already automatically see that they are equivalent, because just like fractions, if I were to look at this and do this, I can look at my denominator to start. I could say that 5 times 2 is going to give me 10, and that's true. So if I multiply 2 times 2, I should get 4, and I do. So these already, I can tell these are equivalent. But let's use our proportion, our cross products to do this. So what we're going to have here again is 2 over 5 is equal to 4 over 10. And what we're going to do with the cross products is I'm actually going to circle these. Some people call this the butterfly. Remember we did this actually again when we were doing our percent proportions, is over of equals percent over 100. So 2 times 10, that gives me 20. And that's going to equal 5 times 4 right here. 5 times 4 is also 20. That means that these are a proportion. 2 to 5 is the same as 4 to 10. And again, that one was pretty easy to see. Sometimes they're not as easy to see. So we want to kind of see if they're going to work or not. Let's try another one. Let's take a look at this one here. We have 6 over 16 is equal to 14 over 56. And again, we're just saying yes it is or no it isn't. So actually I should go back here. This is yes, it's a proportion. On that one, it checked out. So we're going to see if this one is a proportion or not. So I'm going to again do my butterfly. Okay, 6 times 56, that gives me 336. And then it's going to equal 16 times 14. And when I do that math, though, I get 224. So is that correct? Is it a proportion? No, it's not a proportion. This does not equal each other. Therefore, no, it's not a proportion. Okay? So that's literally how we're going to be determining if two ratios are actually a proportion or not. That's what we're going to be doing. And then we're going to take it a step further, and we're actually going to start solving for proportion. This is where we would have x or y or some kind of variable for one of our numerators or denominators. So let's say we have this. X over 4 is equal to 9 over 10. Okay, well, first off, if I was doing like I did on that first example, can I do anything to 4 to get 10? Can I multiply it by anything or divide it by anything? I can't. It doesn't work. So this is where I definitely have to use my cross multiplying or my cross products. So I'm going to go ahead and multiply 10 times x. Now I do it like this. I just draw a little arrow. So that's going to be 10x, because remember x times 10 is the same as 10 times x. And then I'm going to do 4 times 9, and 4 times 9 is 36. Okay, so now I have a one-step equation. Makes my life pretty simple. I have 10x, so I want to get rid of the 10. That means I'm going to divide both sides by 10, because remember 10x means 10 times x. So I always do the inverse operation to solve. So I'm dividing by 10, because 10 times x, dividing by 10 is the opposite. And I have to do it over here as well. When I divide 36 by 10, I get 3.6. And that is my answer for x. Don't panic that it's a decimal or a fraction answer. That's okay. Sometimes in this case, when we're doing proportions, the numerator or the denominator may be a decimal or a fraction. So that shouldn't be anything to worry about when you see that. Let's do one more like this. Let's say that I had 2 over 34 is equal to 5 over y. Okay. Again, I'm going to cross multiply. So this is going to be 2 times y. So that's 2y is equal to 34 times 5. That gives me 170. We're going to get rid of the 2. Divide both sides by 2. Oops, that's not 12. Sorry, I don't know what happened there. Divide by 2. And y equals 85. So there's our answer there. So literally that's all we're doing for this. We're just going to solve for the proportions like that. Okay, one of the things we do need to kind of know is some of our frequently used proportions. By the way, do make sure that you're taking notes on this, because you're going to have to make sure you understand all this for next class. A lot of times things like miles per hour, that's something that's pretty common where we would use a proportion. Maybe I was taking a trip and I was going to Baltimore and I wanted to figure out how many miles per hour I averaged. So I would see how long it took me, how many miles I drove, and then I would set up that proportion that way. And then I would change it to figure out how X number of miles per 1 hour. So that's what I would try to figure out for my proportion there to tell me how many miles did I go per hour. Another one might be for like inches and feet or any kind of measurement type of a question like that. Maybe inches and yards or inches and even miles, because it could be a map scale. Kind of, again, the travel kind of situation. If I'm trying to figure out how far it is, if I have a map and I'm figuring out how far it is to Baltimore and it tells me that 1 inch is 35 miles, then I would figure out, well, how far is it to go to Baltimore? And I'd figure out how many miles it would be. It also could be a scale drawing type of a situation where you're making a model, or maybe you are looking at a floor plan of a house and you want to know, well, how big is the room really? So maybe on the floor plan it says it's 3 inches by 5 inches, but those inches equate to 1 inch is 3 feet or something. So you can figure out how big the room might be. Another example would be money per ounce. This I use a lot when I go to the grocery store. Just the other day I was trying to buy refried beans. I like to make burritos. And I was trying to see which can of refried beans were the better buy. So I looked on there, and it tells me that one of them was 9 cents an ounce, and the other one was, I think it was 10 cents an ounce. And I think another one was even 12 cents an ounce. And I thought, well, let me go with the one that was only 9 cents an ounce, because to me they all taste the same anyway. So that's something you can look at there. You might try to figure out like the price per ounce when you're at the grocery store. Another common one is when you're figuring out the price per item. if you're going to a store, maybe like at the ocean front, and you and your friends are trying to buy Virginia Beach t-shirts or something, or maybe you're got guests and they're trying to do that, you would say, oh, look, we can get these 4 t-shirts for $30, so how much is it for 1 t-shirt? And then you can set up your proportions to solve from there. So there's a lot of common proportions that we can use to help us to figure out things in real life. And I think that's all I have for you today. All right, so hopefully it's not too long a video for you. Next class, again, obviously we're going to be talking about proportions. You can use it also for things like indirect measurement. I used this as an example the other day to someone. If you're trying to figure out how tall the building is, well, I can't stand on top of the building and drop a tape measure, but what I can do, I'll draw a little picture for you. If this was the building, okay, and you have windows in your building and everything, love my artistry, right? Okay. So if this was our building, and we wanted to know how tall the building was, well, I'm not going to stand on top of the building and draw a tape measure and drop a tape measure down. But I could stand outside the building, and I know how tall I am, so I can use my height, and I can see what kind of a shadow I cast. And whatever the length of I can measure this. So I know my height. Let's say that I'm 5'8". And maybe my shadow was 2'3". And I know then the shadow of the building was a certain length. Maybe we'll make this 5 feet 10 inches. Then I could figure out what the height of the building is here, because I could set up the proportion. Okay? Oh, there is one other thing. I'm glad I remember this. Let me go back to this. When you are setting up your proportions and they actually are giving you measurements with something, make sure that you set your proportion up first in words, like right here. I would set this one up, if it was miles per hour, I'm going to set it up like this all the time. That means that when I set up my proportion over here, it's always going to be miles on top, whatever that mile measurement is, and it's always going to be hours on the bottom. It has to stay consistent. I can do it the other way around. I can do hours over miles, but it has to stay consistent. So miles always has to be on top. If I did inches and feet, then again, inches is going to stay on top, and feet is always going to be on the bottom as I go to solve that. Same thing with money and ounce. Same thing with cost and an item, if it was t-shirts, right? So it's going to be the cost, and a t-shirt is equal to the same thing, cost and a t-shirt. So make sure when you're setting up your proportions, use words first to set up your proportions. Okay, I hope everybody has a great night. I will see you next class. Enjoy.